we can get started with this session on Cypher Everywhere, which is a follow-up to some of the points that I was talking about in the keynote, and also follows on from the talk we had earlier on today about Cypher for Apache Spark. So we've got three people here to present. Myself, Alastair Green. We have Mats Rydberg, who's part of the Cypher for Apache Spark team and also a member of the Neo4j Cypher language group, and Dimitry Solovyov, who is from Noyeda, which is a technical partner of Neo4j, and Dimity's been heavily involved in the work we've been doing for Cypher over Gremlin. And we're going to talk about how Cypher over Apache Spark actually interacts with a Hadoop environment in a bit more detail. So really that sort of side of things. And we're also going to talk about, well, we've done the spoiler in the keynote. The unexpected bit here is the work that we've been doing on Cypher over Gremlin. I guess the next thing we need to see is that's Mats is back with the new syntax of Cypher for constructing graphs. So that's just a graphic to indicate where we're going in part of this stuff. And this really shows us where OpenCypher is up to from a code perspective. So OpenCypher has effectively a repo that is related to the tooling, things like the grammar and the technology compatibility kit. And there's a new repo for the Cypher for Apache Spark that was only opened up on Friday, I guess it was, yeah? And there is some stuff in terms of website maintenance and so forth. And then there's a private repo at the moment which contains the Cypher over Gremlin work, and Dimitry will be telling us more about that. So I think that the broad direction here is that Cypher over Gremlin is also headed for Apache licensed open source under the rubric of the OpenCypher project, but we haven't quite got to the point of actually working out when and exactly how, what the modalities are with that, but that's sort of where we're going. Now, Neo4j has a Cypher front end, which effectively does query compilation and pre-processes query planning in the Neo4j product. We've taken that Cypher front end and we've made that Apache 2 licensed, so anybody can use it. It's a very sophisticated, parser, ... AST construction and so forth, query rewriting to some extent. And we've used it in all three of these different implementations of Cypher, and that's quite deliberate. So we've got Neo4j, we've got Cypher for Apache Spark, and Cypher over Gremlin is using exactly the same front end as well. And already mentioned the Apache 2 licensing on those two fronts. So really what we're going to talk about two things in this discussion. We're talking about Cypher over Gremlin, work initiated by, sponsored by Neo4j, but conducted on the ground by developers within Noyeda, very effectively indeed. Great technical partners. You may also know them from, for example, the IntelliJ IDEA Cypher plugin was produced by the Noyeda team. This is the Noyeda Labs in Riga. And then secondly, we're going to talk about data lake integration, how we work with Hadoop and Hive and allied matters. And here again, we made a partnership. We've been working with a small consultancy that specializes in the big data ecosystem in London called 510. Unfortunately, none of them were able to be here today in New York, but we'll be representing their work effectively, and Mats will be discussing that. So before passing over to Dimitry to talk about the details of Cypher over Gremlin, just want to remind you, this is a diagram from the Apache Tinkerpop project. Apache Tinkerpop is a project that provides a low-level API called Blueprints, and it also provides a higher-level API called Gremlin. Blueprints API actually originated in work that took place within Neo4j effectively. It's a kind of, and we still have a native Java API, which is kind of similar in terms of its functional intent and characteristics. Above that, Gremlin, and Gremlin is really very much the focus of the work that's gone on with the Apache, with Tinkerpop going into the Apache Software Foundation. So the Apache Tinkerpop Gremlin consists of a traversal API, which represents itself to users as an embedded DSL in your language of choice, which means it's not independent of a general purpose programming language at the point of use. So it's different in that respect from SQL and different in that respect from Cypher. And then there is a Gremlin engine, which many implementers using Gremlin take this engine and actually then have pluggable backends, as this diagram indicates. So you could put different databases behind Gremlin, the Gremlin framework. And actually, Neo4j is, I think, one of the the three reference implementations that are used to maintain the Gremlin, stack, as it were. So at the front, there's a concept that there could be higher level languages that might make it easier for you to program against a Gremlin-based implementation. So we sort of took that red cipher that you can see on the top left, red means they haven't done it yet, as a kind of invitation, well, why don't we do it? Let's have a Cypher language over Gremlin, and hopefully, if this project is useful, it will be picked up, and it will mean that Cypher can become available as an API, a surface, for any Gremlin utilizing implementation. And Gremlin has often been used as a quick way of getting yourself into the graph world, because you've got this software framework that you can put on top of an existing backing store. It doesn't actually deal with things like transactionality, for example. If you use a non-transactional backing store, or one that can't actually span transactions across partitions of a graph, it won't address those issues. But it certainly is a very good way of getting quickly into the world of actually interfacing graphs over existing stores. And we're taking that one level up and saying, well, let's have Cypher at the top of that stack. So what happens here is the work that we're going to see is effectively taking a Cypher declarative query and working out how to map that to the traversal API of Gremlin, and there's a fair amount of complexity in terms of the different places where that has to happen and the different tricks that have had to be performed in order to make that work. But as we'll see, we're going to be seeing, I hope, this kind of capability running not over Gremlin server-based applications or databases like Janus Graph, which is formerly Titan, which many of you will have heard of, but also seeing it running over Cosmos DB, the Microsoft Graph data service. So, just in terms of coverage, there's a lot of the Cypher language that's already covered. I won't go through the details of all of this. On many of these aspects, you'll find that there's some corner case or less used part which hasn't been fully implemented yet. We have in OpenCypher, and we've used it, I think, Dimitry, you found this extremely useful, the technology compatibility kit. 873 scenarios taken from Neo4j's Java implementation test environment, taken out and represented as Cucumber scenarios that can be used with any language, so programming language independent, and enables people to test their conformance to the de facto Cypher specification based on the largest footprint implementation in terms of Neo4j. So that's part of the process of beginning to create tools that constitute alternate ways of formally specifying the actual content of Cypher. That's sort of part of the OpenCypher initiative. It was used here. This is it's difficult. This diagram's a little bit out of date. I believe the lines move just beyond 50% of the scenarios passing at this point. You can view, I don't mind. If you think it means that we've done half the language or the guys have done half the language, that's actually just fine, because this is not a finished project. In some other ways, it probably underestimates the actual effective, useful implementation coverage. Anyway, this is work in progress. So I will therefore pass over to Dimitry to talk further about this and to show some interesting demonstrations of the technology. Thanks.
Hi. Can you hear me well, right? Yeah. Okay. So I'm going to go over a couple of theoretical things first, and then we'll go to live demo of the actual thing. So this is a kind of conceptual picture of all of the things you can do with our Cypher over Gremlin translation, which we internally call the Cypher over Gremlin toolkit. And it's a toolkit because it consists of different parts that kind of inject themselves in the Gremlin ecosystem. And the parts that you're interested in are highlighted in yellow here. So that's the Gremlin plugin which works in the Gremlin console. That's the Cypher plugin which works in the Gremlin console. The Cypher plugin which works inside the Gremlin server instance. And that custom client which essentially uses the same translation module that translates Cypher queries to Gremlin queries as the plugin in Gremlin server. So why all of these different pieces? Gremlin is a kind of, it has different instances of how it works. The usual one that you find is when you download parts of the Tinkerpop project, is that they have a thing called Gremlin server, right? Which is a Java application that allows you to run a sort of an API on top of different backends. One of them would be Janus Graph or Titan. And there is Gremlin, the language, that could be used across other things, not just the Gremlin server itself. And one implementer of the Gremlin language is Cosmos DB. So they have a completely redesigned and remade instance of a service that accepts Gremlin queries. And what the toolkit allows you to do is actually either send Cypher directly to a Gremlin server and then do the translation and execution of a query there, or you can do the translation on the client side and send the actual Gremlin query to a server that accepts Gremlin, which might be less efficient than when you're working in the Gremlin server, because when we're working in the Gremlin server, we actually do the translation to the so-called traversal API, which Alastair mentioned as blueprints, which was the name for the traversal API in Tinkercad 2. So in Tinkercad 3 is just essentially traversal API. So depending on your use case, you can use this translation module in different contexts. Some things that this allows us to do is actually unify usage of Cypher across different databases or backends that accept Cypher queries. And that would be Gremlin server and different types of databases that support Gremlin input. That would be CAPS, that you might have seen in action in a session previously today and in the keynote, and anything else that, that accepts Cypher, including Neo4j itself. What you see here is pieces of code that we use in a demoware application that I'm going to show you briefly, that actually uses an API that we've built completely identical to the existing Neo4j JavaScript client, with the only exception that allows you to run Cypher queries over anything that accepts Cypher. And it works like this. You essentially initialize it in the same way that Neo4j JavaScript driver is initialized, except you can specify other protocols besides Bolt here, which is what we do. And in the center, you see different connections that are used in a React app that serve as parameters to this code and allow you to initialize different connections to different databases. So I'll just move on to the demo. You might have seen a short clip of this application in the keynote. So this is the one. The application is called Cypher Explorer, and this is essentially a demoware. We use it to just show how stuff works. And it's configured in the same setup as it was in the keynote, where we have Neo4j 3.2. Unfortunately, not 3.3, but that's what it's been made for. Connection, then CAPS, the alpha that is currently open sourced, and Genius Graph 0.1.1, which was the previous release before they made the 0.2 release just before GraphConnect. So all of these backends are running in Docker Compose here. They've already started, and you can see the logs for them, right? So that's CAPS demo, that's Genius Graph. They've just been logging some service information up until now. But now I'm going to just run a query. So I'm going to select this and then execute it with a short with a button. Or okay, right. And we have results returned across all three different backends. As you can see, they are absolutely identical, right? So this is working on the social network graph that if you've been to the CAPS demo, you've seen it there. We are just working on a European Union slice of the social network graph here, and this query just returned the list of countries for us. The tabs that are in each column are kind of in the same vein as how it works in Neo4j browser. So we can switch to the code tab here and see the payload that we get from running this across each different backend. And as you can see, the payload is completely the same. And if you've ever kind of looked at the internals of what you get, or the code tab in Neo4j browser, this is the actual structure that gets returned, and it gets returned across any of the backends. If I go back to the logs and try to find the piece of the log where it ran over Genius Graph, hopefully. It's just that cubs logs a lot of things, unfortunately, so it's hard to find here. Right, let's just run something else and maybe we'll be more lucky. Right, so this is another example of a query that we do, that we run over Gremlin, cubs, and Neo4j. Let's take a look if they're actually right, cubs, yeah. So here are 3 tiny lines of what Genius Graph logged when we ran that query, and we can see that we are logging in debug mode that we've sent this query to our Gremlin server instance, which is backed by Genius Graph. And it also logs the translation that, this thing got transformed into. It's a bit different from the one that Alastair showed on his slides, because we are changing this translation every day in order to better suit the corner cases of Cypher semantics, because we are keeping the Gremlin translation very close. It's driven by Cypher semantics, right? And if actually, are there people in the audience that have worked with Gremlin, the language, before? So do you understand what?
That's Dimitry.
So anyone?
Solovyov.
Right. So a couple of people. That's great. So as you can see, this is a usual Gremlin query, and it might look a bit machine-like because it's, of course, it was generated. The way we do it is that we just traverse the Cypher query, and then for each sub-piece of the query, we generate a respective piece of Gremlin, and we keep a bit of context because depending on parts of Cypher, you have to add some stuff at the end or in the middle. But this is what it ends up looking like. So looking at the result here, the graphs are laid out a bit differently because of the layout algorithm, which is force-driven and it's a bit random. But these are the same results, essentially. So we have listed cities and relationships to the Sweden node, which is the country for the cities. Right, so this is one, and this is the identical city here. And if we look at the table, we see that the results in the table are identical as well for each node, and then the relationship between them. And again, the code is just the same across all of different backends. So the nice thing of having a completely identical API built that's identical to Neo4j JavaScript driver is that we can actually use this library in contexts where Neo4j JavaScript driver is used, and the application wouldn't tell the difference, mostly, which is what we did, and I'm going to show you how it works on Azure. So Microsoft Azure has a service named CosmosDB, which was previously DocumentDB, but then they kind of expanded the name because it became multimodal. And one of the models that they support is a graph model, and you can run Gremlin queries on top of things in the database. So here you see the Data Explorer UI in Microsoft Azure that allows you to look at your graph data inside it. And right now it's empty, so I'm doing a g.v Gremlin query, which essentially gives you the traversal from each node in the graph, and since the graph is empty, we don't really get any nodes back. And in the next tab, I have Neo4j browser running that has actually been hacked to work on top of the Cypher client instead of the Neo4j JavaScript driver. And there has been some fixes to support that. For example, you don't really get service information. As you can see, these lines about the database are empty, as well as the counters here, just because this is not Neo4j, right? So we can't really get that information running on top of a Gremlin Cypher-like thing. But what I am going to do is I'm going to, first of all, clean up everything just in case. And now I have a query prepared here that's going to create a small graph inside this backend that will create some star systems, then connect stars which reside in these star systems to them, and then add some planets. So it essentially recreates a small star map of our solar system, Alpha Centauri and Sirius, and their interconnections. I'm going to run this, and the query will finish. And now if in Azure we will run the traversal for the graph, we see that there is now data inside Microsoft Azure from a Cypher query that we ran over Neo4j browser over Cypher client, which got translated into Gremlin, which then got proxied to Microsoft Azure. And if we click around, we can actually see the nodes that got created. So it visualizes them node by node, but if I kind of select one, I can see that this is a star system. It says here it's a star system with the name Sirius, and it's connected to a couple of others, like this one is a Alpha Centauri star system, right? So this is a solar system, and this is a star that's connected to the Sirius star system. And there are a bunch of other nodes here. The interesting thing is that I could now continue running Gremlin queries here and just work with this data, but I don't want to because I can run Cypher. So I can go back to the browser and run a different query that I got prepared. So this one, it matches Alpha Centauri in the graph and then returns every connection that is to Alpha Centauri. And this is the result. And as you see, since the browser doesn't really know that it has been tricked and it's running not on the Neo4j JavaScript driver but on the Cypher client, it works normally, and since the structure of the result is the same, it even can do things like build its visualization because it gets the data that it expects. So if I zoom in a bit, actually, no, I have no idea how to zoom in on this graph, sorry. But this is Alpha Centauri in the center, and there are three relationships that are a member of, and that's Proxima Centauri, Alpha Centauri Beta, and Alpha Centauri Alpha. And everything else works as well. So we can see the table here that works as expected. And this is the trick, is that the browser received the proper structure of the payload that it can continue working with and rendering these results in the table view and in the graph view. So maybe I can just zoom in like this. Yeah. So here. So this is the structure that Neo4j tooling expects. So essentially, if we swap in Cypher client anywhere else, or if you swap in Cypher clients anywhere else inside of your applications that work with Neo4j JavaScript driver, it should just work. Besides the queries that wouldn't be supported, because of course these backends don't support the full extent of the Cypher language. In particular, in Neo4j browser, we actually made some hacks, so it's a bit of smoke and mirrors in that we intercept several call queries because Neo4j browser fetches some service information from the backend that is running on top, which would be Neo4j normally. Right. So I guess that's it. That's the thing that I wanted to show, and it would make sense to pass to Alastair.
Thanks very much, Dimitry. So a couple of points to make before passing over to Matt. We'll look at the sort of Hadoop side of things. What we've illustrated here are some potential capabilities. The demoware is the word. That's a prototype way of looking at an API that might go to multiple data sources and so forth. We're trying to illustrate the fact that we're thinking about how to get Cypher everywhere and how to make it easier, actually, to bring ultimately data into the Neo4j Graph data platform. Because the theme of the next part of this talk is about data integration. It's about connecting to sources of data, which could include existing graph sources of data, to actually enable the utilization of that data within the Graph data platform. And data lake integration is a very important part of our thinking as far as this is concerned, because we see a lot of our enterprise customers, they are either using Neo4j or they want to use Neo4j. They have pre-existing investment in a Hadoop ecosystem, including Spark, and they frequently use that as a necessary source of information for the kind of processing that's required for graphs. So just one sort of introductory slide before passing over to Matt. This picture sort of renders the idea that using OpenCypher in Spark, we can wrangle data out of the lake. We can get data out of the data lake and assemble it into useful subunits as graphs. And then those graphs can be processed. They might be put into Neo4j, transactional insertions, analytic, graph algorithm executions, and so forth. And indeed, snapshots could be preserved and taken back into HDFS and Hive using this kind of capability. And we'll talk first about that idea of the in and the out, the save and the load, and then we'll finally talk a little bit about another aspect, which is the idea of being able to superimpose graph views on an existing lake of data using Hadoop and Spark. But I'll pass over to Matt for data lake integration demo.
Yes. Hello? I'm audible? Great. So my name is Mats, and I'm, as introduced by Alastair, part of the Cypher language group and also the Cypher for Apache Spark implementation team.
That's good. Yep.
And I'm going to show you an example scenario on how to integrate existing data in like a data lake scenario. In this example, it's a Cloudera cluster and data in Hadoop and Parquet files. So you can see here the AWS console. We have a few instances running. In particular, we have 2 Neo4j instances down here hosting social networks. And if you were part of the presentation earlier today, those are the same social networks that you saw there. Additionally, we have a Hadoop name node, master node here, Cloudera manager, Kerberos server, Cloudera director, and some HDFS data nodes. And I'm logged in here, no, not here, here, logged in here as onto the name node where I have the demo deployed, running in the Kerberos cluster. Currently not authorized by Kerberos, so if I try and run the demo, it's going to throw me out. And the demo itself, as you can see, just says no, no, no. So I'm going to use kinit to authorize myself in the cluster, and I'm going to run this demo using the credentials that we have here. See now that we're authorized. And if you want to authorize using a key tab file, for example, I'm also going to show you the Scala code for the demo that is being run. Yeah, good font here. You can just me that here's this weirdness. You can just configure the principal and the path to the key tab file on the pluggable graph source factory libraries that we have initialized with our CAP session here. And these are developed by a technology partner of ours, 510 from London. And what essentially is done is that we've implemented a Parquet file-based graph representation on disk, and additionally support for a Hive SQL view of those Parquet files, so that we can load graphs as stored in tabular formats in the data lake, and pre-ETL, so to say, as graph formatted files. And then we can store them back, different graphs back, or the same graphs. And it also loads here Neo4j graphs, the social networks, and then it loads here the products graph, looks it up via a URL. And I'm just going to run the demo again, and I have a few breakpoints in the demo. And while that is actually loading, as you can see, it starts now to load the products graph, which is a few 100,000 nodes and some millions of relationships. You can actually see it here. So this is, can you see this? It's kind of small. Maybe I can zoom. So this is U, which is a tool that you can get if you're using the Cloudera distribution of Hadoop, and the Cloudera manager comes with a U view. So it enables us to, for example, see the files in the HDFS cluster here. So we have here at the user, Mats, products, that stores a graph in our format. So there are some metadata and some other metadata folder for storing things like the schema of the graph, which is needed by the Cypher processing engine, and then the actual graph representation. And here we're storing just one, but you can imagine many different graph representations depending on what kind of queries you want to issue to the graph. Different representations make more or less sense from a performance perspective. So the one we've developed here is node edges by label, we call it preliminary. So it partitions the graph over nodes with the same label and with the same file, no relationship of the same type end up in the same file. So while that is loading, it's done, press enter to continue. Now we're at this point in the demo. It's loaded all the graphs and we want to start query the graphs. So press enter here, you can see it outputs some Cypher queries in the log. What it's actually doing is for the social networks, it extracts subgraphs of people who are located in the same city and know each other by 1 or 2 hops. And then we say that these people are acquainted with one another. And we project a graph called result of these nodes and the acquainted relationship. And we do the same for the North American, we do that for the North American social network and the European social network. And then we're computing the union of these to get one single graph of all the acquainted people in the social networks. And this one we're actually storing back into HDFS plus Hive at the location user match all city friends. And this is now done in the demo. It's done all the data stuff. So if we go back here and refresh this file path, you can see, voila, there's a new folder, all city friends that we restored it. You can see it has the same kind of structure here. It has the same files. Not the same files, obviously, different data. Same format. And additionally, if we switch over to the database view of things, so that there are no tables, but if I refresh here, can I see that it created 5 Hive external tables that we can query using this here. This is just me cleaning up the last time. Just query one of these. For example, the person, so it's stored back, as you saw here, it stored back the all city friends graph, which was a union of the subgraphs which contained persons who were acquainted with other persons. So the schema of these all city friends graphs are just persons acquainted to other persons, nothing else. And so there's a table for persons, there's a table for the edges acquainted, and then there are some metadata tables. And if you click here, we can see the SQL schemas of these tables. This one doesn't have much just the elementary properties of relationships, an ID, source and target, and a type. But for persons, there's an ID, and there's first name and last name and email, and also the label. So we can execute the SQL query and get a SQL view over the data that we wrote back from CAPS. So we can see that there are some persons, they have some IDs, some emails, and names. So we let the demo continue. From here on, it now computes the more elaborate queries that we produced for this demo. And also now it reads back in this all city friends from the storage that we just wrote it to match for people. And then we switch over to look in the products graph. Again, located in somewhere in HDFS using the URI, and we match for users, because in products in the products graph, we have users who bought products, right? When in the social network graphs, we have persons who know other persons. But maybe some of those users in one graph are the same real world people as the persons who know people in the social network graph. And in this case, we're saying that if you have the same email, then you're the same real world person. So then we project a new graph that U is actually P. Call that graph links. And then we union everything we got. We union the social networks with the links, with the products, and the city friends who were acquainted with one another in order to compute our big recommendation query. And there's no multiple graph features in this one. This is a query that if you're doing recommendations with Neo4j, you probably wrote queries like this before. So persons who were acquainted with other persons, i.e. they lived in the same city, we defined this previously, lived in the same city and they know each other by 1 or 2 hops. And the second person likes some interest. That interest comes in here again, because the A person is a user who bought a product that belonged to a group with the name of the same interest name as the second person that A was acquainted with. And then some predicate that says that that product is good or that A liked it, then we could recommend this product for B. And that's exactly what we return here. We return the product, first and last name of B, and we're going to print that out. And as you can see here in the application right now, it's about to print. So it's printed the header because we can get that immediately. Since CAPS builds on data frames, it's all lazily evaluated. So Spark didn't actually do anything until it had to write the rows of this table. And if you're familiar with Spark, you'll recognize this log output. This is actually the Spark job now executing all its stages in order to print this table that we see here. And so apparently Life of Pi is a good recommendation for the build mirror person. And then it executes writing recommendations back to Neo4j. So what do you want to do at the end? Well, now we have some recommendations. We could either push that back again into HDFS. We're not doing that in this demo. Or you could push it out to some other storage, let some analysts look at it, see, were these good recommendations or not? Do I need to change my recommendation algorithm? Do I need to do something else? But in this example, we're actually writing this back to the social networks again. So we're taking all the results and we match for persons with those names, and we're setting this P should buy product, P should buy property with the product name. So new queries can then be issued to the social networks looking for these should buy properties, and then you can understand which persons should be recommended what products. And that's the end of this demo. And you can, again, you can inspect these graphs here, but I think we're running out of time. So I'm actually gonna switch back here.
Thanks very much, Matt. There's a lot of stuff going on there, but the one thing that I wanted to really sort of draw out is there's a reason why we didn't just write the data into HDFS, but we put the Hive, QL, DDL view on top of that. And that's not so obvious when you look at this demonstration, because it's, we create this format which is effectively maps the data frames in Spark, and we push it down into HDFS. We take files in directories which are mapped to tables, which effectively just lifted up into memory and become data frames in Spark. But there's another evolution of this, because one of the big problems that people have is their existing data that was never modeled as a graph, and the problem of how to actually extract or distill a graph view from data inside the data lake. And that's the thing that I want to sort of finish on. And I'm going to have to talk about this pretty quickly, but I was at a meeting of the ISO SQL Working Group 3, which is the committee that defines the SQL standard, last week, and we were talking about the issue of how to think about graph data in the relational context, and that's actually relevant for us in Cypher as well. And we were discussing exactly the model that we've just seen from Matt, where we've got labels, effectively tables for labels, which map data frames in the Spark world. And this is the bit that sort of matters, I think, because if you imagine that we've got tables, which might actually be views, and we could, in the big data world, using Hive, make those views. We can make those views pluck any columns that we want from any tables that we want to represent a table for a label from a graph perspective. Once we've assembled those views, if you imagine you had the tools to do that, you could then say, well, those views or tables are associated with labels, and there are things about labels that are different from views. Like, for example, they might have keys. So we might have a unique key for a particular node label, or a unique key for an edge label and a relationship label. And once we've got that kind of label understanding superimposed on these tables, if we understand that, then describing the graph is basically a matter of assembling a set of labels for nodes and a set of labels for edges. And possibly in some future evolution, we could have a more complex schema that would constrain those relationships and say, you can only connect persons to cities and person pets to cities. You can't use the lives-in relationship for anything else. That's kind of music of the future, but it's something that we're interested in both in Cypher, and there's been some discussion in the SQL world around that. But the thing that I really want to leave you with from this is, if those views and tables represent your user-defined understanding of the data inside the data lake, and it could be, by the way, your user-defined understanding of the data in your Oracle database, And you can then have a mechanism for defining how that actually maps together as viewed as labels. We can then put that together and say that's a graph. And that could be the framework for snapshotting the data that you have in your data lake into a graph format for graph processing. You could do that every night for your nightly view. You could use this as the template for how you actually pull up data and shape it in the kind of with the data wrangling facilities that we've seen over these two presentations. So I think that's a very powerful direction that we intend to pursue within Neo4j in order to be able to easily absorb your data and lift it up into memory without moving it. Take the data in HDFS, bring it into memory and manipulate it as a graph. I've run out of time, last slide won't happen, but anyway, that's, thank you very much indeed.